we will look at a problem related to how to write down a recurrence relation and how to calculate or determine the characteristic of the limit, and also how to determine what will happen to the fish in this particular tank in the long term. So example, fish, like all animals, need oxygen to survive. The fish in a certain tank use up to 15% of oxygen in the water each hour. So the consumption of oxygen is 15% for an hour. And due to the action of the pump, more oxygen is being pumped into the tank every hour, which is 1 part per meter cube each hour. So 15% of the existing oxygen is being used each hour, and 1 part per meter cube is being pumped into the oxygen every hour. Okay, so these are the key information you need to pay attention to. The oxygen level in the tank should be maintained. So it's ideal when the oxygen level is between 5 and 7 parts per meter cube for the survival of the fish. And the initial concentration of oxygen in the tank is about 6 parts per meter cube. Okay, so the first question here is write down a recurrence relation to describe the oxygen level. So in order to write out the recurrence relation, you have to consider all the information I highlighted earlier. And we need to see whether the limit exists or not. So this will be based on the value of A for the recurrence relation we wrote in part 1. And we also need to determine in the long term whether the fish will survive or not. So the long term here means is related to the limit, okay, for this recurrence relation. So in order to write down the recurrence relation, okay, example, if we are going to take F as the Fn, subscript n, as the particular symbol which represents the oxygen level in the water after n hours. Okay, so Fn plus 1 equals to, so this is about the remaining oxygen level. So therefore, Fn plus 1 would be 0.85 multiplied by the level of oxygen in the earlier hour, Fn, plus 1, because 1 is the amount of oxygen being pumped by the pump into the fish tank, which is 1 part per million. And we know the initial concentration is 6 part per meter cube. Okay, so therefore the new recurrence relation would be Fn plus 1, subscript n plus 1 equals to 85% of the previous hour oxygen at with 1 unit of part per meter cube for each hour. Okay, and part B says to determine whether a limit exists or not, we always focus on the value of A, which is the coefficient of UN, or in this case is Fn. Okay, this is 0.85, and since the 0.85 is between -1 and 1, so therefore the limit exists for this particular linear recurrence relation. For the third part, we are expected to determine whether the fish will survive in the long run. Okay, and then so for that we need to calculate the maximum or the limit of the oxygen level in the tank, whether it's between the 5 and 7 part per meter cube level, okay, for the fish to survive. So we calculate the limit. So B over 1 minus A. So the B for this problem is 1 from the earlier recurrence relation we identified, and the A is 0.85. So substituting B as 1 and A as 0.85, we will obtain 6.667. And now we need to check this limiting value of the oxygen in the tank against the ideal value, which was given between 5 and 7 part per meter cube. And 6.667 is between 5 and 7. Therefore, it is the ideal environment for the fish to survive.